That's all we had to do. That means that you can now write a sentence of code. In spoken languages, a sentence is a complete unit of thought. And what we did was wrote our API so that they became sentences that expressed one complete unit of thought. And instead of a period, we used a semicolon to say that's the end of our complete unit of thought. And the idea behind fluent interfaces is to create sentences of code. Because if you look at regular code, you just have to know where it stops. Because it's, set this, set, and then you'll start setting a bunch of other stuff, but you just have to know as a developer, oh, that's where that one stops and the next one starts. Whereas if you write fluent interfaces, it's clear where they stop because the semicolon is where they stop. So I obviously did this on one of our projects, but is there anybody else out in the world that's crazy enough to be doing this? Well, in fact, there are a bunch of places where this style of code is starting to show up. And one of them is this open source library called Hamcrest. This is available from Google Code. This is a helper for JUnit unit tests. For the expectations that you create in JUnit, Hamcrest lets you use fluent interfaces to create those expectations. Instead of saying assert equals this, comma, that, you can say assert that this expected thing is this other thing. And it reads much more like a sentence. This is just an add-on to JUnit. In fact, it's included with JUnit 4, but if you're still using JUnit 3.8, you can download Hamcrest. It's just another import that you use, and now you can start writing more readable expectations. In other places this is heavily used are in mocking libraries like JMock. And in fact, this uses a slightly different kind of fluent interface. It's all this stuff in the middle right here, where you say that the classifier object set number method is going to be called once with any integer passed to it, and the classifier is perfect method will be called once and it will return true, and then I'm going to call the set is perfect method once on that form object. I have two mock objects in here inside that expectation, and they've written it in such a way so that you can write complete units of thought as a line of code. They're actually using a pattern here called functional specification rather than method chaining, which is a pattern I used before. That's another common pattern, a common way of writing DSLs. And this is not just restricted to the Java world, because if you look at the more recent versions of InUnit and RhinoMock, which is a unit testing and mock object framework for the .NET platform, they're doing the exact same thing. This is what a RhinoMock test looks like. Actually, this is not even, this is a RhinoMock test. We say assert is not null and expect call list.count return 5. Another really nice place where this is being used in the Java world is this behavior-driven development testing framework called EasyB, which is written in Groovy. And this is actually an interesting case because one of my colleagues, Dan North at ThoughtWorks UK, created behavior-driven development. The idea is you can write requirements that read almost like English, but they're actually executable tests. The nice thing is if you can read the requirements and make them executable, then you cut down on more translation between business analysts and developers. But the problem was he created BDD and then created JBehave, which is written in Java, and the syntax just was hard. It was hard to get Java to be fluent enough to be effective. But then when Ruby became popular, they created this thing called RSpec. And RSpec used DSL techniques in Ruby to make BDD really work well. And the Groovy guys took this idea and re-implemented that in Groovy. So this is what the unit tests look like in EasyB. You create scenarios with a description, and in between all of the things, you can write actual code. You can say before, then this is the initialization stuff, and it should do some stuff, and it should do some stuff. You can actually write the expectations in there, and then watch it fail, and then add code to watch it pass, to make it pass. And it's readable, executable requirements for the code you're writing. So how far can you push this? Well, it's hard in Java because Java is very, very particular about things like parentheses and curly braces and semicolons and things like that. It's much easier in dynamic languages because they have much more flexible syntax. So a lot of the work that you see being done in domain-specific languages now are happening primarily in dynamic languages like Groovy or Ruby, and that includes the Java version of Ruby, JRuby. And in fact, here's an example of a simple DSL written in Groovy, the dynamic language version of Java. The DSL parts of this are these lines of code. Now this compiles to Java bytecode, so it's indistinguishable from the platform as to who created this. What I want to do is make 1 pound of flour work. Now clearly you cannot do this in Java because primitives don't have methods that you can call on them. But in Groovy, primitive integers are really instances of Java lang integer because there are no primitives in Groovy. And Groovy also allows you to come along and add new methods or properties to existing classes. So you can say integer, this is Java lang integer.metaclass.getGram, that creates a gram property, which returns the value of the integer that you passed in. That's what delegate int value does. And now I can create a grams property as well, that is the plural version of gram, and it just does the exact same thing as the one before. And I can also create a getPound method, which returns the number of grams times 453.59237. That's how many grams in a pound. And I can create a pound, pounds, LB, and LBS property and write that DSL 1 gram of flour, 5 pounds of something else. You can do this in Groovy by accessing the meta class of built-in classes, and these are the Java classes that are underlying this. This is even easier in Ruby because you can just reopen the numeric class and add a gram method, and it has this alias method, which is built into Ruby, which makes it really easy to do aliases for those guys. And so that exact same code is even cleaner in Ruby because you have to do less work to do it. And in fact, you can push this a long way in really flexible languages. This is an example of a DSL written in Ruby that looks pretty much like just text. But it turns out that this is easily converted into actual Ruby code, because when you look at it as if it were code, then you can think about, well, the first bit of that is a method call. That flour is the first parameter. Has is what's referred to in the DSL world as a bubble word, meaning that it makes it more readable, but it doesn't add any to the technical definition. It's just there to make it more readable, so it bubbles away and goes away. And the second parameter is really just name value pairs. And in Ruby, when you call a method that has a hash as its last parameter, when you call it, you can just give it comma delimited name value pairs, and it'll automatically convert it into a hash for you. So you can really push this a long way in a language that is as flexible as Ruby or, of course, JRuby. This is, in fact, how Ruby builds frameworks. If you look at Ruby on Rails, it's not really much more than internal DSLs written on top of the existing Ruby language. And that's part of the secret to its success. There's very little code there. It's just a thin layer of DSLs on top of the existing Ruby code. But you may ask, okay, well, how does this apply to now, as in today? Let's go back for a second to our reader strategies I was talking about before. Remember this code that I talked about before? This is how we configured the reader strategies that we had created. We created this reader strategy framework, and then to actually create reader strategies, we used this configuration code. We could write this code in a different way if we wanted to, like this. This has a lot less noise in it. This is, in fact, legal Ruby code that expresses the exact same intent that we had before. But let's be realistic. As Java developers, if we were going to write this stuff today, right now, we'd probably write it like this. That's why there are so many XML configuration files out there, because we have this combination of framework and configuration code.